Sven and Christoph, I'm very much looking forward to your talk. The stage is yours.
Yeah, thanks for the kind introduction, Florian. So this talk is about a journey that Sven and I have been on from like early 2018 to late 2020, together with our colleague Petra from TNG and 3 Mercateo colleagues. And the goal of this journey back then was to move Mercateo's data warehouse to the cloud and to modernize it while doing so. During this journey, we have made a lot of learnings, but before we share them with you, Sven will shortly introduce Mercateo.
I will. Okay, I think you can now see my screen. Okay, so let me quickly introduce Mercateo to you. The company I work at operates 2 big B2B platforms. One is called Mercateo.com, which is a marketplace for procurement, and Unite.eu, which is a large network for buyers and sellers. We have sites all across Europe, in Germany, and we're basically growing at 20% each year for, I think, the past, let's say, roughly 10 years. So, needless to say, that produces lots of data and also produces a few data problems or challenges. So to tackle these challenges, we started in late 2018. We started this project, and we collected 6 key learnings, so to say, which we want to share with you, alongside with a couple of pieces of our journey. So let's dive right in. The very first learning is called building evolutionary architectures. So what's that? That's an interesting idea. When we started our journey, we asked us, what is the right data architecture for our company? And it quickly became apparent that the answer is probably none. There is a better question. The better question we came up with is, how do we make an architecture which is adaptable to changes? Because in data, actually lots and lots of things change all the time. On the one side, it's the data sources. There's new data flowing in, new software components which produce more data. And on the other side, the use cases like machine learning and business intelligence. So there's lots of dynamic parts that move all the time. So we decided we wanted, instead of building the right architecture, we wanted to build one which is able to adapt to changes. Now, there's the concept of building evolutionary technology architectures. And this basically says we can look to nature, and at nature we can we can see what are the key ingredients to actually building such changing architectures. Nature has 2 such keys, and actually not much more. One is the idea of a fitness function, and 2 is the idea of an appropriate degree of decoupling. So what's a fitness function? Well, the fitness function is basically some function which we can throw our current iteration into and then see whether it actually moves us closer to our target. So for instance, we can use fitness functions whenever we have an important architectural decision coming up and then evaluate these criteria we come up with. An appropriate degree of decoupling is something that's actually really uncommon for some reason in data. Data people are for some reason fan of monolithic applications and tight coupling. Indeed, like the whole idea of a data warehouse or a data lake actually is to tightly couple things together to generate value by this coupling. And I think like in the past 2 years, the idea of a data mesh appeared, which goes into the opposite direction, but yeah. Okay, so let's talk about our approach here for these 2 keys. So for fitness functions, we decided to choose 2 simple fitness functions. One being the data quality and the second being the lead time. Data quality, we try to measure in the percentage of days with running bugs in one of our major data sources. So that's what we consider. So we consider a day when there's one running bug in one of our major data sources, which would be, for instance, products or the order data, a day with low quality, and the other day is the day with high quality. The second in fitness function is the lead time. So that's basically the time from someone says, hey, I need this kind of data to the delivery of this kind of data. So an example, and I'm also going to introduce some terminology here. So if a product manager wants to have a list of orders as a report, that's kind of the start of the lead time measurement. Then there might be like some kind of order REST API, which makes this data available, provides this data. It's the data provider. This order REST API data could, for instance, come in this form. It's a customer one timestamp, which is some typo in there, some order status, which is 5 in this case. Then there's some person, usually in the central data team, who ingests this data. This is called ingestion, like taking the data from the provider, putting it into a central data warehouse. Then there's usually another person who transforms this data with another tool, turns this ingested data into readable information. So for instance, here we could turn the customer number 1 into a name, Jane Doe. We could clean the timestamp, and we could replace the order status by something that's easier to read, like order placed. And then after the data is transformed, we usually have someone who actually builds a nice report on top of this. So makes it a little filterable, puts it into some nice business intelligence tool, maybe like does some graphical stuff on top. So that's the idea. So we have the ingestion, the transformation of data, and then we have report building on top of that. So, and this whole process is basically the time it takes, the lead time. So it can be quite long sometimes. Now let's talk about decoupling. So at Mercateo, we're trying to do 2 kinds of decoupling. One is organizational, and the second is technical. About the organizational decoupling, I'm going to talk on the next slides. About the technical, I'm going to talk in the next section, in the next key learning. But suffice to say, like in technical decoupling, we are actually, so before we started our project, whatever part of our stack we touched, we were in danger of breaking all of the whole system. And now we are actually able to very simply exchange our ingestion tool. We can exchange our transformation tool. We can exchange our database, which stores the data. We can also exchange our business intelligence tool without touching the other components at all and without breaking the other components. So that's an important part. And before that, what we actually had to do was to replace every single one of these things before we were able to have this kind of flexibility. But why do we actually want to decouple? So coupling has value and decoupling has value. I looked at this quote from the company Confluent, which are the founders of the tool Kafka. The idea is loose coupling lets components change independently of each other. So we get freedom. Tight coupling lets components extract value from each other. I'm going to explain that in a second. So these are the typical 4 data team organizational forms. In the middle, you have the fully centralized data team, which has all these 3 steps I just explained: the data ingestion 1, transformation 2, and the building of reports 3 inside one team. Then you can cut off basically part 3 and put like people in marketing or sales and departments to do this kind of report building. You can of course also cut off step 2 and have people who also transform data in marketing or sales. And of course, you can like have one individual analytics team in each department if you want to have to. This kind of goes into the direction of a data mesh. So we realized we had some kind of bottleneck in this organizational structure, so we decided to actually change what we had. We started with a fully centralized form, which is a fully centralized form, which is the whole team taking all of these tasks. And that kind of worked very well for a couple of years because they were able to well, share knowledge. But at some point we had to hit the bottleneck. So we decided to move to the architecture on the bottom right, where we decentralized analytics engineering. So we actually didn't just decentralize the reporting of things, but we also now have 2 to 4 people inside the departments which transform data. I mean, it's just two to three people, but it was a very important step. So when we moved from the fully centralized to this decentralized format, we actually had an explosion of dashboards and newly curated data inside our company. Okay, so I'm now gonna jump into the next section, which is the learnings about replacing ETL with ELT. And as far as I can see, there are no questions so far. So let me move on. So the second key learning was to replace ETL with ELT. So what is that? ETL and ELT are both architecture choices. And moving from the one to the other is about decoupling something. I'm going to explain that with an example, the one we just saw. So I said we wanted to display a list of orders with their status. So we have this source API, which delivers this kind of data, customer one, a messed up timestamp, and an order status. This kind of data we can transform into this data, Jane Doe, timestamp, order placed. Now, ETL versus ELT is the question, when does this transformation happen? If we have ETL, which stands for extract, transfer, load, all in one step, it means we would extract the raw data from the sources, transform it on the fly, and then load the final result into a database, the line we just saw. On ELT, we would extract the raw sources, load them into the database, store them there, and then afterwards do the transformation. That sounds like a little change, but actually it's a huge change. So in ETL, in our database, we would probably have this one table with like the new data. But if we were to do ELT, we would probably end up with up to 5 tables, one containing the raw orders, one containing the cleaned orders, where we cleaned the timestamp, then the raw customers, because we also need this mapping from customer one to Jane Doe, which we did on the fly in the ETL case, and the raw mapping of order status 5 to order placed, which we also did on the fly in the ETL example, and then the final table. So what's so much better about having 5 times more data? Well, it means other people can also access the raw data. And if we want to adapt or create new information, new reports, we actually already have lots and lots of data inside our data warehouse, and we don't have to go to the sources. So that's an important part. Before we started our project, we had lots and lots of ETL. So like this tightly coupled architecture where we pulled data from one source, from another, joined them together, filtered them, wrote them into one database, and took them out and wrote them into another database. We even refreshed our business intelligence tool depending on this whole cycle. So it kind of was a mess. Like it looked like a huge monolithic thingy where everything depends on everything. Now, the point where we realized we need to change to ELT was when we also thought about the decoupling on the organizational structure. Because if we wanted to enable other people to access, to also transform data, they needed access to the data. But we can't ask like an analyst in the sales department or marketing department to go to the source data. We need to provide them with the raw data inside like some central structure. And the second point is that the quality was one of our fitness functions. So we wanted to like really increase the quality, and having smaller units, which transferring the T out, taking the T out of the ELT makes simply produces 2 smaller units that enabled us to test these 2 units independently, which made for much better quality. So this is the first iteration we did. On the left-hand side, you see the data lake, which is on AWS S3. Then there's Amazon Athena as a query engine, which is based on Presto, by the way, which basically allows us to read the data from S3, from its object storage, using SQL syntax. And then there's the business intelligence tool on top of that. This architecture was the simplest iteration we could do, but it enabled us to decouple the access to the raw data from viewing and from the extraction and loading phase, which we previously had coupled. But this architecture also meant that we only had very light transformations because we had to do them like right inside the SQL. So of course we needed more transformations of data. So we added a database, and the DBT, the data build tool, which is provided by the company DBT Labs. It's a cool tool. It just does transformations only, does nothing else, just transforms data inside our data warehouse. But it meant by introducing this tool, we now also decoupled the transformation part of the transforming part from the other two parts. And after our third iteration, which we are currently doing, we also put up a small interface in front of this database, which basically allowed us to decouple the business intelligence tool from the database. So how does that look like? We use the feature, there's a feature called DBT exposures, which basically mean our transformation tool produces model tables which are just meant for viewing. And these are the only ones we use in our business intelligence tool. That means that in our business intelligence tool, all queries are very simple. There's just like select column 1, column 2 from this table. And that's all there is. So that means that now we can actually really easily exchange our business tool, which we are currently doing. It just means like porting these very simple queries over to another tool, which is easy because there's no logic hidden in there. Okay, so let's take a look at what might come next in our journey from ETL to ELT. Well, there is a new concept. So ELT is kind of becoming the de facto standard in the industry. But the industry also noticed that always taking the whole bunch of raw data is sometimes not good enough. That means sometimes you're actually taking too much. You kind of need to do some transformation while you're extracting data. One very specific example is personalized data. In terms of the GDPR, you actually want to filter that out, because if you put personalized data into your data warehouse, you kind of have to delete it afterwards, which is simply unnecessary. And it also means you store data, you don't just process it. So that's not a good thing. You want to have some kind of lightweight transformation while extracting the data. Lightweight transformations could mean like some JavaScript function, some TypeScript function, something small that filters stuff out from E to L. The thing is just like currently good tools in this space are simply missing. So we haven't ventured further into that direction. Okay, so there are no questions as far as I can see. So I would like to hand over to Christoph for the next section.
Yeah, thank you very much, Sven. So far we have talked a lot about decoupling and especially decoupling the data transformation tool from other tools. So the thing is that now we have decoupled it, we somehow have two interfaces. One that is towards the data ingestion tool, which provides our raw data, and the other one is towards the business intelligence tool, which we provide with model data. And actually, this now is a great opportunity for automated testing of data quality. And luckily, our data transformation tool is based on DBT, as Sven already mentioned. So there we already have a huge out-of-the-box functionality for data testing. So we can just specify data tests in YAML files that look as following. So here we specify the sources. Sources is just DBT lingo for tables that have been created by another tool, like our data ingestion tool. And there we have a namespace for everything that comes from the shop system. And inside that namespace, we have a table that is called raw orders. And that table has a list of columns, one of them being the order ID, where we can leave a small description, like this is a 10-digit identifier for orders. We will come back to that later, and we can specify small tests that will be run against that column. And the test will be uniqueness, so that every entry in this column is unique. No order ID occurs twice. And that the values are not null, so there is an order ID in each of the rows of that column. And yeah, then we have another field that is called status, where we only want to accept some limited amount of values like status that we know. that in that case would be placed, shipped, completed. And every time another or a new status occurs, we want to be alarmed. So we test for that feature. And then there's another column that says customer ID. And there we want this to be not null. And we want something that is called referential integrity. So we want each customer ID that we see in this column to actually show up in the customers table as well. So that's why we're specifying that reference. And again, when this guarantee is broken, then we will be alarmed. And yeah, so for this raw customers tables, things would look similar. So again, there we have this customer ID, which this time we test for uniqueness and not nullness. And the nice thing about this kind of syntax where we can specify tests and description is that this serves as a basis for an auto-generated data documentation, which is nothing more but a website where we have, like, for each table, we have this kind of website where we have a short description. What does the table do? What columns does it have? What types do they have? Here we see the descriptions again, and here we see these tests like uniqueness, not null, foreign key, and so on. And another thing about auto-generated data documentation is that by using the references of the models towards each other, we can have a dependency graph that is more or less a map of our entire data warehouse. So on the left-hand side, we have all the raw data tables, and then we have like one layer of tables that is mostly dependent on the raw tables and so on. And to the right, we have the more modeled data. So that was the detour about data documentation. Now back to data testing. So we already had these built-in tests. Sometimes, like in the case of this 10-digit number, we want to have a test that is still quite generic, but also a little bit custom. So we can write a custom test for this. It's still generic because we want to be able to test any column of any table, whether the entries are 10-digit numbers. And in DBT, we can specify these kind of tests by using a mixture of the Jinja2 template language and the SQL language. And what we actually do here is we write a select query that chooses all the rows that violate our assumption. And so here we select all rows from the model where the column of interest is not a 10-digit integer. And if like this select statement returns an empty result set, then everything is fine and the test is green. And if there is something, then the test is red, and we also get the information, yeah, this row violates the test conditions. And these kind of generic tests can be referenced in the test section of the previous YAML file. And now if we want to move forward to even more specific tests, like for example, you could imagine that in this case of the order table referencing the customers, that due to data protection regulation, customer data gets deleted after some time. And then maybe if the order is more than 1 year old, it's okay if we can't find this customer ID in the customer table anymore. So we're only testing that all orders that are younger than 1 year have a valid customer ID, valid meaning that they show up in the raw customer tables. And then again, we can just write a SQL query that looks exactly for those rows in the orders table that violate that condition. And since here we already have the references to the tables, we actually do not need to reference that test in the YAML files anymore. It just gets run automatically and knows which tables to look at. And yeah, so if we're now asking why do we actually want data tests? So the thing is that data tests are an important part of data documentation, similar to unit tests being a part of code documentation in languages like Python or Java. And also data tests allow a faster and simpler debugging of transformation logic. So if one day the transformation logic fails, we might actually see that even at the point where the raw data comes in, one of our assumptions is already broken, and then we don't end up looking for errors in a higher level of transformed data when the error already occurred in the beginning. And in the end, data tests also give developers more confidence that their data is correct. So all in all, data tables become like methods in programming that every developer can use without having to know the exact implementation. And then, since we already have that comparison to unit tests, but data tests are not exactly unit tests, we also want to have proper unit tests that are not don't test data, but test logic, being data transformation logic. We actually consider this kind of unit tests being small pairs of input data and expected output data for transformation logic. And however, this kind of testing is not supported out of the box by DBT, so we had to implement a small testing framework on our own using PyTest. And now this allows us to do test-driven development of transformation logic. Yeah. And then we also have a third kind of tests, which are infrastructure tests, where we have like unit tests, like does the data warehouse work as expected? Does it accept JDBC connections? And also integration tests, like can the data transformation tool connect to the data warehouse? And does the BI tool answer to HTTPS requests? And actually, these are part of the deployment pipeline. And while we have been writing lots of tests, we haven't forgotten to actually version all the things. So we have versioned our infrastructure, which is specified as code, which comes with the benefit that we can create similar environments for dev integration and production and keep them in sync. That we also versioned our data ingestion logic and data transformation logic, which actually simplified collaboration and parallelization during development and also allowed the teardown and redeployment at any time. And of course, versioning is not a means to its own end. So we had to actually do a lot of work to make versioning work. So we had to come up with a branching strategy. We had to come up with peer review culture. And we also had to come up with automated build and deployment pipelines.
Yeah, thanks very much so far. We have two questions in Slack. The first one from Daniel. He asks, having a relational database, it would be possible to enforce the DBD-tested properties of the data. What are the advantages of the test-based approach here?
Yeah, that's a very good question. So the thing is, like in our case, we actually have a relational database, being Postgres, that actually supports to enforce those kind of properties through the schema. However, when we look at data warehousing in general, then other data warehouses like the one by the cloud providers like Amazon Redshift or Google BigQuery, they don't support this kind of thing. And the reasoning is that by enforcing these kind of, especially the foreign key relations, you have to make sure that these properties are guaranteed at any time. So if you first load the orders and then load the customers, these guarantees like the foreign key reference might be violated for a short amount of time. And then like your data ingestion logic would fail and everything would stop. And by actually going away from like enforcing them at any time to only testing them, we can like live with these short amounts of time and very less about these things when we actually program and schedule our data ingestion logic.
Mm-hmm. Thank you. We do have a second question from Aaron. He asks, are these DBT tests executed against the real data sources? And if so, continuously? What happens if an assertion breaks, manual intervention, or how to enforce the constraints?
Yeah, also a very good question. So DBT doesn't really talk to our data sources. Somehow talking to the data sources is the task of the data integration tool that just copies data from sources into our data warehouse. And those DBT tests actually run against those copies inside our data warehouse that we tend to call raw data. And actually we control when these DBT tests are executed. So we will see in the next slide how you can see this testing as part of a build pipeline, and this way decide at which step in your build pipeline you want to run these kind of tests.
Mm-hmm. Thank you. So far, we don't have further questions.
Okay, then speaking about build and deployment pipelines. So like as I already mentioned, we version all the things. So we also version our infrastructure by specifying it as code. So this is like an example for the code that specifies actually the Postgres instance that is the heart of our data warehouse. It's just an AWS CloudFormation template, and there you have like some header information, and then you have a list of resources, and one of them is a database instance that has a lot of properties, like especially here, the kind of hardware that we want to use. Everything parameterized because we want to use different hardware depending whether we are running in production or in development. And also here we say we want to have Postgres as a database engine, and we want to have version 12.7. And then we also want to have some properties about monitoring and backups and everything. And the nice thing is that these things like backup and maintenance are actually done by the cloud provider, so we don't have to worry about them. And yeah, another nice fact of specifying this infrastructure as code is that we can continuously deploy and test our infrastructure. So here we can see such a deployment pipeline. So let's wait until it returns back to the top. Here we have the source code, then we deploy it, and then we run our integration tests. And this way we can make small modifications. What happens if we change that database parameter? What happens here? And like integrate it continuously. And yeah, another part of the continuous integration and deployment story is data transformation logic. So what we actually have is we have here a build pipeline for our data transformation logic, where in the first step we run some tests, and it's too fast now for me to follow. So again, first step building, second step running tests, third steps promoting the container image to development, fourth step promoting it to integration. And since we're working on a feature branch here, there's actually no promoting it to production. This can only happen after we've merged it to master. And benefits of continuous integration of data transformation logic is that transformation logic gets tested centrally, so there's no more works on my machine, and that developers can make sure that they are talking about the same artifact while debugging. And yeah, one last aspect of this is, which comes back to Aaron's question. So actually the execution of the data ingestion and transformation logic can be seen as a build process for data models. So like a build pipeline by itself. So here we can specify different steps, like the run step, which actually runs the SQL code to fill the tables with data. And we have a test step that like runs these kind of tests that we've seen before. And we have some step that generates the data documentation. And some people even execute this kind of transformation logic in their CI system, like for example, GitLab or AWS Code Build. However, we decided to use Dexter instead, which is sort of an orchestrator for data ingestion jobs and data transformation jobs that allows a more, I don't know, which allows a better modeling of dependencies between jobs. There's also other orchestrators in the field, like for example, Apache Airflow or Prefect that you might have heard of. And yeah, back to Sven, I'd say.
Thank you. Okay. So I want to just ask about a little bit about data governance. So this is one of the key learnings. We also found that data governance, data discovery, simply should be like at the forefront of every single new data project. So because there's an explosion of space of new tools in that space, which actually make it really easy to do both discovering data, like finding data in the jungle you usually have, and also to govern it in some central way. So before we started the project, we had basically outdated Confluence pages to manage our data, and we had at least no testing of live, of like no statistical testing of the data that was flowing through our system. After we finished the project, we still mostly had the same thing, at least outdated Confluence pages. And as Christoph just described, you do have some testing of live data and based on the DBT schedule tests, which run on schedule. But what we do not have is some kind of statistical testing, which kind of like would alarm us about outliers. So good that we are building a new evolutionary architecture, right? So what is to come in that direction? We will be trying to get a data catalog running, which should be linked to DBT because DBT already has linkage information and so on. And we, of course, want to introduce something like Great Expectations, which is a great tool for actually doing just that statistical data testing. So basically like building a profile of the data that is currently there, the different columns. And then I said like alarming about outliers or checking for, well, whatever we want to check for, basically. So we're really looking forward to that. And we think that's going to increase the quality in our system by quite a bit. Next, I'm actually going to come back to the question Daniel just asked about why not put the tests, why put the tests to where the business logic is. Basically, so the key learning is that we should consider functional data engineering and immutability. And it's the concept which is transferred from programming, of course, like from functional programming. The basic idea is that data engineering actually is programming. We're making our lives much easier if you consider everyone who is working with data, analysts, data scientists, machine learners, analytics engineers, everyone, simply treat them as developers and then let them use best practices in software development and programming. For going to functional data engineering. Some ideas here are, so why do we want to do functional data engineering? Well, it's to make stuff reproducible, which is very important in analytics and data. So we would start to avoid states and mutable data. So basically, data shouldn't change anymore. If we have a pipeline, like something that turns data around from data into information, and we put 2 arguments in, this should always yield the same results. So the data underlying that should never change. And the pipeline actually shouldn't change as well. If we want it twice, it should just yield the same result. Some selected implications of that would be, we should probably have an immutable staging area for data. So that means every data we take into our data warehouse, data architecture should be append only. We should never modify data. This would allow us to recompute every single piece of analysis we've made in the past. If we do have a change in business, in logic, for instance, if we do want to change some pipeline from A to B, we should actually do that inside a task. Like we should write before the state do X, afterwards do Y, so that we can recompute what we did before. If we have changed business logic, we should actually try to not store them inside tasks, but inside data. So for instance, if we're calculating with a tax rate of 90%, and then COVID happens and it gets reduced to 16%, we shouldn't just put that right into some statement, into some Python code. We should actually try to store a table of data inside our data warehouse and then simply join that together. We should do dimension snapshotting, which basically means that if you do have some kind of data, raw data, which simply changes for whatever reason, we actually simply take a photo of that, like on day 1, on day 2, on day 3, and then we store all of these different snapshots in our database so that we, on our side, actually have immutable data. If we were to partition our data, we would do that on event processing time. That's a subtle but important difference, because doing it on timestamps means like we could actually insert data with all timestamps, and then the partitions are not immutable, and then we got to rewrite partitions, which is totally no fun. If we do it on the event processing time, we don't have to do that. So before we started our project, we did some snapshotting of data actually, to like creation of historical data, but it was a very limited set of snapshots that we had. And we actually had complex logics to do incremental loads of large data sets, which were simply deleting data or like modifying data we had in our data warehouse. But we realized we need to change. For one reason, I like this quote from Maxime, who's the founder of the creator of Airflow and Superset, and also I think the CEO now of the company, Preset. And he says, it's simply about reproducibility and replicability. They are so fundamental to everything we do in data and in analytics that we simply got to try to introduce this functional data engineering. So what we did was to simply put it in lots of different places. For instance, we started at our data lake. We started to have mostly immutable data ingestion. We tried to not do overrides, but to append only. If we were to ingest data where we previously did like these kind of manual deletes and updates of data, we started to do complete reloads of the whole data set. Then in our data warehouse, we used DBT snapshots on that exact raw data, so that we were actually snapshotting the different states of the data. So we are creating this kind of immutable staging area. And we are also using a feature called DBT seeds to actually encapsulate this kind of changed business logic inside small tables. So the tax rate is actually a good example. We have a table which just has these kind of tax rates, which we seed into the data warehouse. Okay, so that is the end of the learning section, and I cannot see Florian, so I think there are no questions. So I will hand back to Christoph.
Yeah, thanks, Sven. So we have now talked a lot about the learnings we've made during our data warehouse journey at Mercateo. So if you want to read more about this kind of stuff, we have a few reading recommendations. So actually, the people who developed DBT came up with something called the Analytics Engineering Guide, which is a very comprehensive work on basically how to bring software engineering best practices into the world of data warehousing. And then you have Maxime Boschman's article on functional data engineering. And last but not least, Sven has written a nice blog post on a Mercateo blog about how Mercateo is actually rolling out a modern data platform where you can read all the stuff we've told you and even more. And yeah, so finally, if we want you to remember 6 things from this talk, then they are the following. So the next time you're building a cloud data warehouse, make sure that you implement evolutionary architecture, replace ETL with ELT, or if you start from scratch, just start with ELT. Test and version all the things. Integrate and deploy continuously. Keep an eye on data discovery and data governance, and appreciate functional data engineering. Thanks.
Yes, thank you very much, Sven and Christoph, for this interesting talk. I think a versioned, functional, and tested data warehouse, it sounds really cool. I think I would really appreciate to have that too. Do we have questions? Further questions? Some were already asked. Maybe from the room, from the on-site.
So I would have a short question, and I can simply ask it here, I guess. So I think the functional data engineering part, that is very interesting, and I like it. But one problem I have when I would think about doing it is data should be immutable, yes, but that does mean that I can't delete anything anymore, right? I mean, whatever I put into that system needs to stay forever. And probably that's not really possible to do that always, right? I mean, there are also laws probably that I'm not allowed to do that. Or is everything, do you need to take care that everything is anonymized and everything before you put it in so that you can keep it forever?
Okay, so yes, so that's of course a good point. So with regards to the GDPR, for instance, what we actually do is, so I would say we do delayed data, of course, like personalized data. We actually follow a very simple principle there. Because we have this kind of functional approach, we are actually able to recalculate our complete data structures from the very first layer. In the parts where we do get personalized information, we actually simply recompute them the moment the source actually deletes that, which is our approach to tackling that problem. So yes, we do delete that kind of data at the raw level. So we specifically do not snapshot this kind of data. And we actually also do the work and identify all the personalized data in our data warehouse by prefixing it.
Okay, thanks.
We have another question from Thomas. He asks whether you think about using Apache e-charts for your front end.
Okay, so that's he means the business intelligence front end, right? Yes. Okay. So no, we actually just decided we just did a large evaluation of business intelligence tools, and we actually just selected Tableau as our new business intelligence tool, simply because we wanted to have a tool which allows lots of people to actually create data inside our company, like create dashboards, create reports, but also like the more underlying structures.
Mm-hmm.
I hope that answers the questions if I got it correct.
he wrote yep, so it seems like he asked a further question whether you have tools, advices regarding data lineage and data retention, like deleting personal data along GDPR. We already spoke about this briefly.
Yeah, so it's a good question, and unfortunately, I gotta say, it's a half a no. So we're not that happy with the tooling out there for our, especially not for like deletion of data. So our approach is this kind of very simple approach, like simply recalculate everything from time to time from the source. In terms of lineage, we are currently relying on DBT for lineage, because like DBT has this complete lineage graph, which it provides via SQL. And that's all we got currently. But it serves the purpose. So.
I do not see further questions, and we are almost at the planned end of our time. So I think that's the end of our session here. I'd like to thank you very much again for this very nice talk, and everyone enjoy the rest of the Big Tech Day.